We are live. So let's see if Cayman comes clicking in. It says 0 people watching right now. See if he clicks in pretty fast. He's sitting there. And he might have watched on Tuesday and not be watching today. But I think it'd be fun if we all said hi, Cayman, if he clicks in. Oh, look, somebody's watching. Everybody say hi, Cayman.
Hi, Cayman.
He can't see you. The camera's pointed that way. Okay, everybody but Tarnbeer said hi, Cayman. Tarnbeer's being a poop this morning. All right, guys. Questions. What do you got? It could be about particular problems. It could be about concepts. It could be about things that you wanted to ask but just really didn't have an opportunity to from older stuff. It could be about focus and applications. Anything? Anything that's bugging you? Neela, were you about to talk and then I talked right over you?
No, I was just scaring my dog.
Oh, darn it. Okay. You know, I can hope. Anything? Thunder.
29C. How are you supposed to find the inverse of that?
Which section?
4.3.
4.3 29C. I can probably tell you, you're not going to find the inverse. Instead, let's look at the problem. You're going to use the property of inverse derivatives. Let's see, 29C. Let f of x equal cosine x plus 3x. Oops. Clear. And the question says, show that f has a differentiable inverse. Find the inverse at 1 and the derivative of the inverse at 1. So let's remember something here, and this is agreed? Reflection across y equals x is an inverse function. So if I look at this point, and I'm going to call this A, comma B, there is a derivative f prime of A. Agreed? And I can calculate that. Slope, of course. Now, let's think about the derivative of the inverse function, not drawn to scale, by the way. The derivative of the inverse function, f inverse prime, at, well, if, let's put that point there. If this is A comma B, do we agree that that point right there on the inverse is B comma A? So this would be the derivative of the inverse at B, and that's the derivative of the function at A. So I've got two slopes. I've got the slope of the original function at A comma B, and I've got the slope of the inverse at B comma A. And this is all just principles of inverse. Inverse is a reflection across y equals x, which means every point switches. AB becomes BA. Turns out there's a relationship between those two numbers. The derivative of the inverse at b is equal to 1 over the derivative of the function at a, and vice versa. The derivative of the function at a equals 1 over the derivative of the inverse at b. So when you're looking at a problem like this, the question is, first off, what are my points? I need to know a and b. Because when I know a and b, I will also know b and a. So when I look at this problem, they ask me to find f of 0 and f prime of 0. So that means that we can assume that a is 0. Agreed? So what's b? Well, cosine of 0 is 1, plus 3 times 0 is 1, which means that b is equal to 1. So I now know my point. F prime of 0 must be equal to 1 over f inverse prime of 1. Agreed? I don't want to switch those. And probably more usefully, the derivative of the inverse at x equals 1 is 1 over the derivative of the original function at x equals 0. And the reason I say more usefully, because I can find the derivative of this. F prime is equal to, well, whatever the derivative of that is. And then I can plug in 0, and then the derivative of the inverse function must just be 1 over whatever I get. Now, how do I prove that the derivative exists? Well, does this derivative, let's generalize this a little bit more. Hang on just a second. So I'm going to go back just a step to, well, actually, I'm going to go back just a step to here. If I need to prove that this exists, what must be true of that?
Also exists.
Has to exist and
Not 0.
can't be equal to 0. There's the important point. If this derivative exists, which, yes, it does, it's a differentiable function. If it's ever equal to 0, then there are places where this derivative doesn't exist. So if you read that question carefully, it says prove that it is differentiable for all values of x. If this is ever equal to 0, then that's not differentiable for all values of x. Let me double check what the question's actually asking. Show that f has a differentiable inverse. Actually, so we're not even concerned of differentiable. There could be places, it could still be differentiable in places. So when we're talking about that, there could actually be places where it's not always differentiable. But, so what's the derivative of cosine? Negative sine. What's the derivative of 3x?
3.
So the derivative of the inverse is 1 over negative sine, let's say at b, a plus 3. Does that ever equal to 0? So that would be equal to 0 when negative sine a is equal to, or plus, excuse me, plus 3 is equal to 0, agreed? Which means that this is that sine of a is equal to 3. Could you guys list all of the places on the graph of sine where it's equal to 3? You can't, or there aren't any? Why not?
Because it never equals 3.
Yeah. Sine cycles between fact, this can never equal 0, which means that this function is differentiable for all values of x. And so this is an interesting question, though. When they say a differentiable inverse, there's a couple possible ways to answer that. You could say a function is differentiable on this interval, or you could say it is just differentiable, which means everywhere. And so if they say show that it's differentiable, I would say that they probably mean show that it's differentiable everywhere, because otherwise they'd say show that it's differentiable in this interval. So just the plain old, is it differentiable everywhere in the domain? And since the domain of cosine is infinite, then that means that we're looking to prove that it's differentiable infinitely. That makes sense? This is a complicated concept. When I started teaching calculus, I hadn't thought about this in a very, very long time. Man, it took me a while to wrap my head around it, because there's so many little marks. There's the inverse marks. There's the derivative marks. There's the A's and the B's, which are switching back and forth. And I think really the way to think about this problem really is visualize two functions that are inverses of each other, visualize A and B, recognize that therefore the other one has a B and an A, and then go to this. So you have to do two things. You have to take the reciprocal of the original derivative, and you have to switch the points. If you think about those two things, reciprocal of derivative, and part two, switch A and B. Do those two things, this becomes a much easier problem if you think of it that way. Cool? All right. What else? Any other questions? I'm going to look at email and see if maybe Cayman, assuming that that's, oh, we got 2 people watching. I want to see if either of them emailed. Hey guys, if you were watching this and you have a question, send me a very quick email to say I have a question, and then we'll figure out how to get the question. Refresh. Sure wish the chat function was available on our live streams. Stupid school. So while I'm waiting for email, should I tell you what I bought yesterday, calculus related? I was at that little antique store down by Kelly Road, and I decided to go in and look at the records and the books and the movies, because usually by the time I go through the antique store, I'm sort of tired of looking at stuff, and then I don't look at the records and the books and the movies because it's fiddly and you have to look at every single one. I found a 1946 calculus book, and I started to read it last night. It's amazingly similar to what we're doing now. You know that definition of limits that I was talking about yesterday? And I thought this was super interesting because I learned it. I want to say that I learned it the way that I taught you guys, although that was quite a few years ago and I'm not 100% sure. No. I want to say I learned it the way it was in the book. Sorry, I had it backwards. So the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. In the book, it says that the derivative is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Exactly. It's the same thing, except we're writing h instead of delta x. I remember this being a confusing concept. And now looking at what we teach, I'm thinking, as Neela said, there's a lot of x's in that equation. And all it does, there's no reason you have to say delta x except to recognize that this is a change in x. You're moving from one point on the graph to another point on the graph. But when you write it that way, all of a sudden there's 1, 2, 3, 4, 5 x's, and you have to change in your head that this is actually an x and this is actually an x and the rest are changes in x's. And that's so much simpler. All by changing one small notation that doesn't matter at all. And so, yeah, so reading this definition last night, and this made perfect sense to me reading the old math book because I've now been teaching calculus for 8 or 9 years. So that made perfect sense to me, but the more I looked at it, the more I thought, wow, H is better because it's simpler. It's easier to distinguish between the point and then how much we moved. I just thought that was super cool. I thought that was interesting that the calculus hasn't changed, not at all, but that the notation changed just a little bit and it's easier. And I don't know if it was intentional or who knows why they changed it, but boy, it was sure cool. Okay, I have not gotten any emails, so let me refresh one more time. I'm going to assume that the 2 people watching the live stream don't have questions. I don't know what else I could assume, because I don't think there's a significant lag. So I should have gotten emails by now if they were sending me emails saying I have a question. So, all right, guys. Then here's the rest of the period. We've got till 9:05, and then we've got T3. I got nothing else for you. I'm just going to let you work. You can work on calculus. If you run out of enthusiasm for working on calculus because you just have spent so much time thinking about math, please feel free to switch over to what?
I just leave it since I don't have a 4th period.
You mean, can you leave at 9:05?
Yeah,
I don't know.
I was allowed to inform this class.
Well, I'm not saying you can't, so you don't have to argue with me. I honestly don't know. I have no idea what the rules are. I'm perfectly fine with it. I was kidding. I was kidding on the you don't have to argue with me part, right? Because yeah, if the rules are that you don't have to stay for T3, I'm perfectly fine with you leaving at 9:05. Doesn't bother me at all. Yeah. But the rest of you, by golly, on the live stream, that just made a loud thumping noise. This thing's very sensitive, I've discovered. Yeah, no, that's cool. All right, I'm going to shut down the live stream.